Our next topic in this chapter is origin of magnetic moment. Okay, let us see. The materials are made up of atoms, consist of a nucleus surrounded by electrons revolving in their orbits. We very well know about this. Okay, whenever the center is a nucleus and the electrons have been rotated surrounded by the nucleus, because nucleus is a positive charge and electrons are a negatively charged ions. So these orbital motion of electron established a magnetic field, and hence we get orbital magnetic moment of electrons. Coming in, these orbital motion of electron established a magnetic field, and hence we get a orbital magnetic moment of electrons. While revolving around the nucleus, the electrons spin about their own axis, which results in a magnetic field, and we get a spin magnetic moment of electrons. And then the nucleus in the nucleus, nucleons in the nucleus also spin, resulting in magnetic field, and we get spin magnetic moment of nucleus. In this concept, we are getting the magnetic field from three concepts. One is due to the electrons revolving around the nucleus, we are getting orbital magnetic moment due to electrons. Then the other is, while revolving around the nucleus, the electrons rotate itself about its own axis. Then it results a spin magnetic moment of electron due to its own rotation, okay, about its axis. And next, the nucleons in the nucleus also spin, that those are also spin and gives a magnetic field, and that results a spin magnetic moment of nucleus. So all the three combined will give a origin of the magnetic moment. Now let us see what is the origin of the magnetic moment. And next, see here what we are observing in this diagram. The center, that is the atomic nucleus, the electron which is revolving around the nucleus, and as an axis there is a magnetic moment which we are providing, okay, and direct spin of electron. The figure B represents the direct spin of electron, okay, that means the direction of spinning is in this direction only. Next, orbital magnetic moment of electron, that is a nothing but a Bohr magneton. Let us see. Consider an electron of mass m, charge E, revolving around the nucleus R, is the radius of the orbit V, be the linear velocity of an electron, omega be the angular velocity. Okay, so m is the mass of electron, E is the charge, R is the radius of the orbit, V is the linear velocity of electron, and omega is the angular velocity. Then the linear frequency of the revolving electron equals to omega by 2 pi. So time period of the revolutions, that equals to 2 pi by omega. Okay, linear frequency is like this, and the time period of revolutions is 2 pi by omega. The revolving electron in a circular orbit establishes a current, and it is given by current I equals to charge per time period, that is equal to electron charge is negative, so minus E by 2 pi by omega. Now it will be minus E omega by 2 pi. So we are getting two equations here. Now the current establishes a magnetic field around the circular orbit, so that upper surface acts as a south pole and the lower surface acts as a north pole. Now the area of the orbits A equals to pi r square, because area of circle is a pi r square, okay, because the electrons are revolving in a orbit. So this orbital magnetic moment is pointing from south pole to north pole. So the magnetic moment of loop mu equals to Ia, as we earlier said in the definitions. Now the mu orbital equals to minus E omega by 2 pi into pi r square. Now mu orbital equals to minus E omega r square by 2. Now orbital, that is equals to E m omega r square by 2m according to the mass of the each electron. Now the angular momentum of the revolving electron is given by That's angular momentum equals to linear momentum into radius. So linear momentum, that is equal to L equals to mvr. Now L equals to mvr, we can write it as m omega r square, since v equals to r omega. Okay, now mu orbital E equals to minus EL, because m omega r square can be written as L. Now according to the third equation, mu orbital equals to minus EL by 2m. Again we are getting three equations here. Minus sign indicates orbital magnetic momentum and orbital angular momentum opposes to each other. That is the sign of the minus. Okay, and next, according to modern atomic theory, the angular momentum of electron in the orbit is determined by the orbital quantum number L. Now angular momentum L equals to LH by 2 pi, where L is a 1, 2, 3, 4 SPDF orbitals. Then the equation, the previous equation 5 will be, what will happen? EL value will be replaced. So mu orbital equals to minus E by 2m into LH by 2 pi. Now ELH by overall, that's a 4m pi. Okay, now mu orbital equals to all other values except L will be considered as mu b, where L equals to 1, 2, 3 and so on. So mu b equals to EH by 4 pi m, that's the values is 9.27 into 10 power minus 24 ampere per meter square. That is known as a fundamental unit of magnetic moment, and it is called as a Bohr magneton. Okay, now let us see what is the spin magnetic moment of electron and the spin magnetic moment of nucleus, that is said to be nuclear spin magnetic moment. Now spin magnetic moment of electron. The spinning electron about its own axis establishes the magnetic field, and we get magnetic moment is known as spin magnetic moment of electron. So mu spin equals to gamma, then to 2 by E by 2m into S, where S equals to H by 4 pi. And mu spin equals to gamma, that's a gyromagnetic ratio according to the spinning of electron about its own axis. So gamma equals to E by 2m into S value will be replaced. Now mu spin equals to the value 9.4 into 10 power minus 24 ampere per meter square. That's a constant value. And again, the nuclear spin magnetic moment. In addition to electronic contribution, nuclear spin is also contributes to the magnetic moment of atoms. So now mu according to the nuclear spin equals to EH by 4 pi mp. That's mp is the mass of a proton. Now mu equals to mu nuclear spin equals to, here again a constant value. Okay. So this is about the orbital origin of magnetic moment. So mass of proton is 2000 times heavier than mass of electron. So spin magnetic moment of nucleus is negligible because mass of proton is 2000 times heavier than mass of electron. Let us assume it is big, so the spin is almost completely not possible. Whenever it occurs, it is a negligible value. So whenever we are taking the magnetic moment of an atom, that is the sum of only orbital magnetic moment of electron and spin magnetic moment of electron only. Okay, next, in the next class we will discuss about the classification of magnetic materials.